This is part 2 of lesson 4.05, Properties of Ionic Compounds. So again, you will find that sugar, a covalent compound meaning two nonmetals that are going to what? Share or exchange electrons. Share electrons. That does not conduct. But the table salt is an ionic compound. It's going to conduct electricity. Why? Because you have those positive and negative ends. In solution, hydrated ions carry electric charges. So hydrated mean that they're dissolved in water. Electric current is passing through a solution. So it's just as if these wires were attached by wires. Electric current is the ability to move charged particles, such as electrons, in a wire or in a solution. There is little electric current in pure water because there is no net electrical charge. So not much current moves. But in nature, do we ever have pure water? No. We have animals living in there and everything that the animals eat and get rid of after they ate, and rocks and all kinds of other stuff. But if you actually have pure H2O, then there's not much of an electrical charge. When you add sugar, the sugar molecules dissolve and move about in solution, but the sugar molecules, which have covalent bonds, are not electrically charged, and therefore they don't help with the current. They can't be part of it. When you add table salt, though, water molecules dissolve and surround the electrically charged cations and anions. The ions are free to move about in the solution. Because the ions are electrically charged, because you have that positive negative, their movements are an electrical current. The strong ionic bond accounts for the properties of ionic compounds. The electrostatic interactions between ions make the ionic bond very strong relative to other types of bonds, for example, covalent bonds. The strong ionic bond requires high energy to be broken or loosened. Ionic bonds have high melting points and high boiling points relative to the elements that make them up, and compared to covalent compounds. It takes a lot of energy to get that positive and negative apart. The strong ionic bonds hold the ions tightly packed in a crystal lattice. Ionic compounds are hard and brittle, which means that they are going to break instead of bend. In solution, water molecules surround ions, interact with them, dissolve the crystal, and allow the ions to move freely, which therefore is going to be the conducting of electricity. So ionic bonds, again, what's your perfect compound to think of? Table salt. The formula is NaCl, sodium chloride. It's between a metal and a nonmetal. Ionic bonds are very strong. They can dissolve in water to form a solution that then can move the ions, in other words, conduct electricity.